All right, let's take a look at today's lesson. So we're going to be working with negative rational exponents. That sounds so exciting, right? We were working with positive rational exponents previously, but the added little nuance here is we're going to be working with negative rational exponents and we're going to be factoring. That's really the key of this lesson is negative rational exponents plus factoring. Okay, so let's work on that. So if you recall, let's just think back to previous factoring. You know, if you were asked to factor, say, you know, x to the fourth minus x, I don't know, to the first. Okay, what would you do? Well, you would look to see which of the exponents was smaller, and then you would factor or divide that out, right? So we're dividing, factoring is dividing. And so we would, in our heads, we would think, okay, what would that look like if I divide that by x, I divided that by x. X to the fourth divided by x is x cubed. X to the first divided by x is 1. And so that's how we factor. You know, that's how we typically factor. We choose the smallest exponent and we look for common bases. So in here, they're actually telling us what to factor. A to the 1/2, b to the 1/2. They're telling us to divide that out or factor that out. So we just need to, again, be sure we're cognizant of the fact that factoring means dividing. We're basically dividing those terms out of the original terms. Okay, so let's do that. So we've got a to the 1/2, b to the 1/2. Open up our bracket or parenthesis. So let's see, we've got a to the 3/2. Now let's think about, let's get rid of this so I have some room. Let's do some thinking over here. So this is what we're thinking. Now you don't have to write the thinking part out. It's just up to you. So let's think through this. So we want to take the a to the 3/2, b to the 1/2. We want to divide it by a to the 1/2, b to the 1/2. Okay, we see that those go away. And if you recall, when we are dividing terms with they have the same base, this has an a and this has an a, we would subtract the exponent. So 3/2 minus 1/2. So we'd say 3/2 minus 1/2 would give us 2/2, which is 1. So this would give us a to the first power. Okay, which you know we don't have to write to the first power, so minus. Okay, so let's do some more thinking. So now we've got a to the 1/2, b to the 3/2, and we're dividing out. What we're factoring out is a to the 1/2, b to the 1/2. Okay, we see that goes away. A to the 1/2 over a to the 1/2 is 1. Okay, so we have common bases here. Base of b, we're dividing, so we would subtract the exponent. So we would say 3/2 minus 1/2 is 2/2, or 1. And so that's the thinking that we would go through in order to factor this, in order to complete this task. Okay, and so I'm just going to put those in bubbles. You don't have to write all that out. I just want to help you think through what is it that we're doing. So let's take a look at number 2. We are told to factor, and we're thinking, whoa, okay, well, let's see what we got. So what do we're looking for, so here's what we're looking for. Number 1. Okay, we look for common bases. And then number 2, once we find the common bases, we will determine the smallest exponent, because that's the one we're going to factor out. We factor out the smallest one. Okay, so this is what we're looking for. We're going to look for common bases, and then we're going to factor out, we're going to determine what the smallest exponent is, and that's the one we're going to factor out. So as we look at this problem, we see that these bases are the same. x minus 1, x minus 1. That's the same. So that's what we're going to factor out. We don't have any match for just a plain old x, so it has to just kind of stay there. So we need to look then at the exponents. So we've got a positive 1/2 here and a negative 1/2 here. We have to think, okay, which one is smaller? Well, negative 1/2 is smaller than a positive 1/2, so there we go. We did step 1. We looked for common base. We got a common base of x minus 1, and then we determined the smallest exponent, which is negative 1/2. So here we go. We're going to factor out the x minus 1 to the negative 1/2. Open up our brackets. Okay, so let's do a little thinking box. So we would think, this is what we would think. So I've got x minus 1 to the 1/2, and I want to divide out of it x minus 1 to the negative 1/2. We know when we have common bases and we're dividing, we would subtract the exponents. So we'd have 1/2 minus a minus 1/2, which is basically 2/2 or 1. That's interesting. So when we divide the x minus 1 to the negative 1/2 out of the first term, okay, this is term number 1. This is a first term, and this is my second term. So when we factor that out of the first term, we simply get just x minus 1 to the first power. And we know we don't have to write the first power. So then I've got this minus. Okay, then, well, x minus 1, if we want to think about it, but x minus 1 to the negative 1/2 over x minus 1 to the negative 1/2, that's the same thing, it's just 1. So we're left with this x comes down, and that would be a 1. Okay, so let's just clean that up a little bit. So, we've got x minus 1 minus x, so we're just left with a negative 1. So to rewrite this, so we have x minus 1 to the negative 1/2 times a negative 1. We would want to keep the exponents positive, so I would pull that x minus 1 to the negative 1/2 to the denominator. So my final answer would be negative 1 over x minus 1 to the 1/2. All right, so if we start in exponential form, which we did, remember we talked about those words, exponential versus radical, we want to stay in exponential form. Our answer needs to be in exponential form. Whew, we got through the first one. I know these are a bit crazy. We can do this. So let's take a look at number 3, and let's again look for common bases. Let's see, I've got an x squared plus 2 and an x squared plus 2. Okay, great, that's my common base. So now I'm going to look for the smallest exponent. Let's see, same scenario here. I've got to look at 1/2 or negative 1/2, and negative 1/2 is smaller. So I'm going to factor out the x squared plus 2 to the negative 1/2. Okay, we're factoring it out. Okay, so let's do our thinking box. So these again, just little thinking boxes. You don't have to write them. It's just going to help us process. We're going to think. Let's see. So I've got x squared plus 2 to the 1/2, and I'm going to factor or divide out x squared plus 2 to the negative 1/2. Okay, so I've got 1/2 minus a minus 1/2, which would be 2/2 or 1. So for term number 1, this is term number 1, this is term number 2. Remember, terms are grouped together by multiplication. I'm simply left with an x squared plus 2 out of that first term. Now from the second term, I've got this subtraction sign, and I've got the x squared. And so let's see, when we divide, let's just work that out for just fun. So this is more thinking. If we take x squared plus 2 to the negative 1/2 divided by x squared plus 2 to the negative 1/2, I mean, those are exactly the same. So anything over itself, you know, that's the same as 1. So I'm just left with this x squared times 1. Okay, so Oh, this is very similar to the other one, isn't it? The x squared minus x squared goes away, and I have a negative exponent there, that x squared plus 1, excuse me, x squared plus 2 to the negative 1/2. So let's shrink this a little bit. Oh, it's not playing nicely. That's fine. Okay, so this would turn into, let's see what we have left in the numerator, 2 over x squared plus 2 to the positive 1/2. So I changed this negative exponent to a positive exponent by moving it to the denominator, since these are attached by multiplication. Whew, that's a bit crazy, isn't it? All right, so let's move to the second page. We'll do a few more of these just to kind of get a feel for what's going on. Again, our first step is to look for common bases. Let's see, I've got a 2b minus 5 and a 2b minus 5. Okay, those are my common bases. And looking at my exponents, I need to choose between a negative 1/4 or a 3/4. I think we could all agree that negative 1/4 is smaller. So that one's the winner. That's the one that gets to be factored out. So I have 2b minus 5 to the negative 1/4. And that's the one we're going to factor or divide out. Let's get our thinking box down here. Okay, so factoring is dividing. So I've got 5b plus 2 times 2b minus 5 to the negative 1/4. That's my term number 1. And I have a term number 2. All right, so I'm dividing or factoring out that 2b minus 5 to the negative 1/4. And these match perfectly and are connected by multiplication, so they go. So the first term, I would simply have that 5b plus 2. Okay, great. Let's work on the second term. This subtraction comes down, and the 3 comes down. Okay, so let's see, what do we have? We've got the 2b minus 5 to the 3/4 divided by 2b minus 5 to the negative 1/4. Okay, so 3/4 minus a minus 1/4 would be 3/4 plus 1/4, which is 4/4, which is just 1. So I'd be left with 2b minus 5 to the first power. Whew, okay. All right, so let's look at what we have to clean up over here. Let's just, why don't we, these are attached by multiplication, so I'm going to pull that down to the bottom. So 2b minus 5 to the 1/4. And in the numerator, we've got the 5b plus 2. Now let's distribute the negative 3. So negative 3 times 2b is negative 6b. Negative 3 times a negative 5 is a positive 15. Okay. All right, so now we just need to combine like terms along the numerator or the top, and we're going to be good to go. Let's see, 5b minus 6b is a negative b, and 2 plus 15 would give me 17, and that would be over the 2b minus 5 to the 1/4. All right, home stretch. Last problem. Ooh, this is a bit crazy. I still have 2 terms. Now you might be wondering, or maybe you're not, you might be wondering, could this work with more than 2 terms? Absolutely, you could absolutely do it with more than 2 terms. Now we just have 2. Let's see what we got going on. So I've got an x plus 5 and an x plus 5. Let's see if we have anything else in common. Oh yeah, we've got an x minus 5 and an x minus 5. So we've got 2 common bases that we need to factor out. Ooh, this is going to be a little crazy. All right, so we've got the x plus 5 to the 1/2 and the x plus 5 to the negative 1/2. So we've got to choose between 1/2 and negative 1/2, and this one is the winner. And then we need to choose between negative 2/3 and 1/3, and that's the winner. So those are the 2 that we're going to factor out, because here, this have the smallest exponents. All right, so I've got the x plus 5 to the negative 1/2, and I've got the x minus 5 to the negative 2/3. Whew, okay, so we're going to do some thinking here. So let's do a thinking box. So I've got 2 times x plus 5 to the 1/2, x minus 5 to the negative 2/3, and we're dividing out of that x plus 5 to the negative 1/2 and x minus 5 to the negative 2/3. Well, these are identical, so they're 1, so that's great. Okay, I've got this 2 left over. So I've got, let's see, 1/2 minus a minus 1/2 would be 2/2. So I just have an x plus 5 left here. All right, that's what I get when I factor those out of the first term. Now let's work on the second term. Okay, so we've got, we have another 2. Okay, we're probably going to be able to we can factor that out. I've got a 2 and a 2. So we miss that at first, but we can fix that because I can just take this 2 and just pull it out here, right? And I've just got the x plus 5. Okay, so now let's work on, let's give it its own little highlighting. So we had this common factor and this common factor. Sorry, little 2's, didn't mean to forget you. We picked you up, so you're good to go. So now let's work on the other, the x plus 5 and x minus 5, dividing those out. So my second term is x plus 5 to the negative 1/2, x minus 5 to the 1/3. And we're factoring out or dividing out the x plus 5 to the negative 1/2 and the x minus 5 to the negative 2/3. All right, what do we have here? So these match perfectly. They turn to 1. Yay. The others are same bases, but they don't match. So we're going to have to subtract the exponents. 1/3 minus a minus 2/3. What does that give us? 3/3 or 1. So plus x minus 5. All right, so you might be wondering, does it always turn into 1? Not always, but these are very nice. They are turning into 1. I mean an exponent of 1. Okay, so let's clean this up a bit. We've got this x plus 5 plus x minus 5. We can combine like terms in there. These are all attached by multiplication. All attached by multiplication, so I am allowed to take this and move that down to the denominator. Actually, they're both negative exponents, so I can take both of them. So let's do that. So the 2, I know it's attached to the x plus 5 to the negative 1/2, but it's only attached by multiplication. It has to stay in the numerator when I pull those others down into the denominator. So I've got x plus 5 to the 1/2, x minus 5 to the 2/3. Okay, great. So what else do we have up here? We have x times x is, x plus x is 2x. X minus 5 is 0. So it turned out that we didn't even need to worry about factoring out the 2 because it's going to clean itself up. So our final answer would be 4x over x plus 5 to the 1/2, x minus 5 to the 2/3. Whew, all right.